Average normal stress in an axially loaded bar. Let's look at some of the learning outcomes. Understand the definition of average normal stress and apply the formula sigma is equal to P over A to solve for the average normal stress in an object. Consider a truss member that is subjected to the tension force P. If we cut along a random point, then, regardless of the section location, the internal force is constant and equal to the magnitude P. And assuming that the bar is uniform, we will have a constant cross-section and the material properties do not change. If the member is subjected to tension, then it will elongate uniformly along its length. So, we can assume that the uniform deformation is caused by a constant uniform normal stress sigma, which is distributed uniformly across the section. Let's look at the side view of the bar. Sigma is the average normal stress at any point on the cross-section. P is the resultant internal normal force at the section, which is applied at the centroid and determined using the method of sections. A is the cross-sectional area of the bar. Since the average normal stress is constant, then the internal normal force is equal to the average normal stress multiplied by the definite integral of dA, which we can just write as the average normal stress multiplied by the area. Rearranging for the average normal stress, we get the formula, the normal force divided by the area. Let's try out this example. The 50-pound lamp is supported by 3 steel rods connected together by a ring at A. Determine which rod is subjected to the greatest normal stress and compute its value. The diameter of the rods are DAB is 0.35 inches, DAC is 0.25 inches, and DAD is 0.3 inches. We will first set up our positive axes. Now we'll need to find all the forces in the lamp, so let's start with the free body diagram. Let's solve for our unknown forces using the summation of forces in the y direction, where AC sine 30 is ACY and AD sine 45 is ADY. Notice that there are 2 unknowns here and we cannot solve, so let's move on to the summation of forces in the x direction. AD cos 45 is ADX and AC cos 30 is ACX. We will write AD in terms of AC. We can now substitute this into the summation of y forces equation to get AC as 37 pounds. Now we can put this into the summation of x direction equation to get AD as 45 pounds. Now let's find the area and the average normal stress of each rod. The cross-sectional area of each rod is going to be pi r squared. And since we are given the diameters, we will divide these by 2 to get the radii. Let's start with rod AB, where the radius is 0.175 inches, the area is 0.096 inches squared, and the average normal stress, using this formula, we get is 521 pounds per inches squared. We'll do the same thing with rod AD, giving us an average normal stress of 634 pounds per inch squared. And lastly, rod AC, which gives 755 pounds per inch squared. Using the formula, average normal stress is equal to the force over area, we get the average shear stress for AB, AC, and AD. Therefore, the rod that is subjected to the largest average normal stress is rod AC.